All right, here we are for Honors Physics, Circular Motion, Universal Gravitation, Worksheet 1. I'm going to try problem number 5 here, right, which says 4.5 kilogram sphere is attached to a chain and is being whirled around in a circle vertically, right? At the bottom of its path, the tension on the chain is 67 newtons. What's the radius of that path if the sphere is traveling at 3 meters per second at that point? So let's go ahead and do a little calculation here. So they kind of gave me a diagram. I'm going to draw it over on my paper. I like to have everything on the paper I'm working with. I suppose ideally I would like print each problem on the page and then work under it. But anyway, so here we go. Problem 5. So here's my here's that sphere, and it's connected by a chain, right? Anyway, and it's whipping around in a circular path. Okay, so here's like the center of the circle. You can see the circular path. That means I'm looking down the z-axis here. Let's see here. I'm just going to go ahead and do my forces right on that sketch. So we'll say ranged forces. There's a gravitational force going from the center of the object straight toward the center of the Earth. Contact forces. The only thing touching the sphere is the chain, which is being stressed. So there's a tension force, all right, going upward on that chain, all right. And there's nothing else touching the sphere, so that's it. That is my force diagram, just tension going up and gravity going down. My coordinate axes, we know that we are going to do our axes. This is along the line toward the center of the circle, so this is the radial axis, right? And then this is tangent to the circle. So that way is the tangential axis. All right, I'm going to call, and again, you say, which way has to be positive for the radial? You don't have a choice. In toward the center. The centripetal direction is positive. I'm going to make, we're moving leftward, so I'm going to make that way positive. Okay, let's see here. Let's go to do sigma F equals ma, most important formula in physics. All right, so I'm going to do my forces. Again, I'm going to choose to look at the radial axis first. We know that in circular motion problems, you are pretty much always going to analyze that radial axis. And it's because we know the acceleration in the radial axis is that centripetal acceleration. We have a special formula for it. We want to take advantage of the fact that we have the formula for the acceleration in that axis. So here we go. When I write this, we always do forces in minus forces out. For the radial, you don't have a choice. So it'll be T minus mg is mass times my acceleration in the centripetal axis. Okay, and there is that equation showing just the variables from the force diagram. I always like to see Newton's second law written that way before we go throwing any numbers in. I'll always ask for that on like tests and finals and stuff. Okay, there is just a teeny bit of physics left. Oftentimes after this, it's just algebra. But there's one more little thing we want to do. We want to substitute in that equation for centripetal acceleration. We know that centripetal acceleration is equal to the speed squared over the radius. So we'll go ahead and we'll substitute that in. All right, and at this point, that's very good because the variable we're trying to solve for, we're trying to find the radius of the circle. There it is. We got it in our equation. And actually, we know the values for everything else here. We know the tension is 67 newtons. We know the mass is 4.5 kilograms. G, of course, is 9.8 near the surface of the Earth. And the speed we were told was 3 meters per second. We got everything except R. Just rearrange, get R by itself, and put in our values, and we're done. So, again, I'm going to like group this T minus mg and throw it underneath. I'm going to move the R over there. So my R is going to be equal to mv squared. And then T minus mg, I'm dividing both sides by. Okay, I can put my values in, and life will be good. So that radius of the circle, let's see here, 4.5 kilograms, right, times a speed of 3 meters per second, divided by that tension, 67 newtons, minus that mass times 9.8. Okay, time for the calculator. Okay, and I get 1.0 round up to 7. So I'll say that's 1.77 meters is my radius. And that's that problem. Okay, I think the only thing I think is pretty straightforward. This one, I think the only thing is recognizing that it's always t minus mg. You say we're not doing t minus mg because t is up and mg is down. We're doing t minus mg because it's inward to the center of the circle minus outward away. Centripetal minus centrifugal. Okay, that's problem 5.